For years, the world was told a tale. Not just raw information, but a deliberately shaped narrative, one that portrayed advanced technology as a towering fortress, with lofty walls, heavily guarded gates, and only a chosen few holding the keys. At the core of that fortress sat something so tiny yet so powerful it dictated the balance of power, the semiconductor. And not just any semiconductor, but the 3-nanometer wonder, a microscopic feat of unmatched speed, efficiency, and precision. It was never just silicon. It was a marker, a threshold, a forbidden frontier that one nation, China, was supposedly destined never to cross. The tale was neat, convincing, and reassuring to those already inside. The rules, we were told, were unshakable. Without the crown jewel of fabrication tools, extreme ultraviolet lithography or EUV, no one could craft the world's most sophisticated chips. These machines, colossal behemoths as large as buses, carried optics so delicate they bordered on perfection, instruments so advanced they seemed closer to science fiction than reality. They were built by one company, ASML, in the Netherlands, and only a handful of allies could buy them. Without access, you were locked out of the game. Sanctions followed like clockwork. Strategies were rolled out. The approach was nicknamed small yard, high fence. Limit the scope, but guard it ferociously. Contain China, stall its progress, deny it the critical building blocks of the digital future. It wasn't just politics, it was strategy. A contest of power played on the battlefield of silicon. And the message was broadcast loudly. Without EUV, China could never advance. Checkmate. But what if that assumption was never the truth? What if the idea that EUV was the only door forward wasn't fact, but belief? Comfortable, convenient, and convenient to repeat. What if the so-called fortress wasn't seamless stone, but riddled with cracks, side doors, and alternate pathways? Quietly, behind the noise of sanctions and headlines, a new storyline began to form. It didn't arrive with a spotlight. No parades, no grand announcements. Just whispers, leaked technical notes, obscure patents, and tiny signals that hinted something had shifted. At the center of this twist stood Huawei. Once a fast-climbing giant in smartphones and telecom, Huawei was struck down at the heart of the US-China tech conflict. Stripped of Google services, pushed out of global networks, cut off from leading-edge chips, many outside observers declared the company finished. They expected a slow fade into irrelevance. But Huawei refused to die. It adjusted, regrouped, and transformed. Instead of collapsing, Huawei became a symbol. A rallying cry for resilience, an emblem of national determination, proof that no external gatekeeper could choke off progress indefinitely. They doubled down on their own ecosystem, launched Harmony OS to sidestep Android, leaned on domestic collaborators, and poured resources into cracking the single hardest barrier, semiconductors. That's where the plot thickened. While Taiwan's TSMC and South Korea's Samsung charged ahead with EUV-enabled factories, China's chip industry worked with what it had. Enter SMIC, Semiconductor Manufacturing International Corporation. By the old rulebook, they were capped, stuck beneath a glass ceiling. But SMIC didn't wait for permission. They took an older tool set, deep ultraviolet lithography, or DUV, and stretched it to its outer limits. Dove was clumsy at the cutting edge. It lacked EUV's precision. To get results, engineers had to rely on a punishing technique called multi-patterning, etching the same intricate structures over and over in perfect alignment. Like carving a masterpiece into stone by hand, layer after layer, knowing that one slip could ruin the entire block. It was slow. It was costly. Industry veterans called it impractical, but SMIC turned impractical into possible. Step by step, they climbed, 14 nanometers, then 7. Analysts dismissed it as a one-off stunt. Then came evidence, devices hitting the market, that suggested SMIC had breached 5 nanometers. Skepticism turned into shock. And now, according to recent teardowns and lab reports, they may have leapt even further, producing chips at 3 nanometers. Not with EUV, not with access, but with older machines, reimagined and pushed past their intended limits. If confirmed, the implications are seismic. It doesn't merely shift the playing field, it tears up the entire rulebook. The very foundation of the West's sanctions strategy, that without ASML's EUV machines China could not compete, collapses. The barrier was never one of skill, it was one of access. And access, it seems, has been bypassed. This is not the end of the technological contest. Far from it. China still wrestles with chip design hurdles, packaging technology, specialized materials, and manufacturing yields. But the myth has been punctured. The illusion of an invincible fortress has dissolved. What was once declared the final move in the game has instead revealed itself to be just another opening move. The world must now face a new story, one still unfolding, one filled with uncertainty, rivalry, and disruption. And its lesson is as stark as it is timeless. No barrier, no wall, no gatekeeper can hold back ingenuity and determination forever. The barrier the world believed unscalable has been pierced. Not with parades, not with flashing headlines, but with silence. Calculated, surgical silence. And that silence is louder than any trumpet. Because what has happened here isn't merely about microchips. It's about control, about stories, about who holds the authority to define possibility itself. For decades, semiconductors were the kingdom of a privileged few. Their supply chains acted as moats, their patents as weapons, their political reach as the crown. The world followed their timeline, their roadmap, their rules. But that empire is no longer unchallenged. A redistribution is underway, not through armies or brute strength, but through innovation sharpened by survival. We stand at the birth of a new age, where advantage may not belong to the richest labs with the most sophisticated machines, but to those who turn constraints into breakthroughs. The word impossible is being redrafted, not in noise and spectacle, but in silence and precision. So when someone repeats the line that China is years behind, remember this moment, because revolutions in chips rarely explode with thunder. They creep forward, wafer by wafer, circuit by circuit. For years the consensus was firm. 7 nanometers was the wall. DUV could not go further. 5 or 3 was a fantasy, a maze of collapsing equations, crushing costs, and physics that refused to yield. Industry leaders declared the path closed. The road ended there. But what if they were wrong? What if the end was only a puzzle, awaiting a mind unwilling to accept the script? What if multi-patterning's inefficiencies, the very thing used to dismiss it, could be turned into strengths instead of flaws? While global tech giants wagered fortunes on EUV, following the official doctrine of progress, something else took shape in the shadows. A parallel struggle. Not of unlimited capital, but of stubborn resourcefulness, relentless engineering, and national resolve. Then suddenly lightning struck, the Kirin 9000s. No rumor. No prototype. A living product buried inside Huawei's Mate 60 Pro. Analysts cracked it open and froze. The heart of the device was a 7nm class processor, mass-produced by SMEC. Not a single demonstration piece. Not an accident. Real scaled production. Born under sanctions. Cut off from EUV. Achieved while working with restrictions so severe it was assumed impossible. And yet there it was, the unthinkable, now physical. The industry staggered in disbelief. But still they clung to their mantra. 7 nanometers was extraordinary, yes, but 3? That was unreachable. Another universe entirely. A barrier demanding entirely new physics, tools, and methods. The verdict was final. It could not be done. Not here. Not now. Not by them. And then came the whispers. They grew into reports. Reports hardened into confirmations. And confirmation detonated into shock. Huawei and SMIC had crossed the line again. Not a rumor. Not a one-off miracle. Real production. The sacred 3nm threshold shattered. And not by EUV, but by DUV. This wasn't force, it was finesse. Multi-patterning wielded with surgical precision. Materials redesigned. Processes re-engineered. Every weakness turned into leverage. While the rest of the world stared at the EUV wall, China carved a hidden path around it, brick by brick, angle by angle. This chip isn't only hardware. It's a manifesto. A declaration that the old order no longer holds the keys. For decades, the assumption was fixed. The future belonged only to those who commanded EUV. That illusion is now rubble. China has written its own roadmap, and it doesn't stop at 7. It has already reached 3, and it won't stop there. The semiconductor clash of 2025 is no longer a one-sided battle. Sanctions, once designed as a hammer, now look like sparks. What was intended to cripple has instead ignited a wildfire. Huawei and SMIC haven't merely caught up. They've changed the meaning of the race itself. And the shockwaves stretch far beyond silicon. The contest for 6G isn't distant anymore. It's unfolding now. Chinese companies like Xiaomi, Oppo, and OnePlus suddenly stand on a foundation of homegrown silicon. No more waiting for approval. No more dependency. With Harmony OS surging and an increasingly self-sufficient digital ecosystem, China isn't following the script anymore. It's writing a brand new one. This is bigger than a manufacturing feat. It's a tectonic jolt. A transformation born of constraint, sharpened by necessity, driven by ambition. The digital dragon isn't dozing anymore. It's wide awake, its roar shaking the world. The real question isn't whether China can close the gap. The real question is whether the rest of the world is prepared for the consequences. Were you ready for this? Did anyone truly believe the 3nm revolution would come from here, from now, from them? And when 2 nanometers, or the next frontier, ceased